standard deviation?
What is this?
It have to be 10.
It's 15. That's the case. In order for what Cassie just said to be 100% accurate, it would have to have a standard deviation of 10. But IQ actually has a standard deviation of 15, not 10. Why? Because they made it be that way. That's how the test is set up. It's set up to have those two parameters. Cassie, thank you for that. That was wonderful. It has to have an average of 100 and a standard deviation because they made the curve be that way. So now my question is this. You can't just start up your program. Well, you could do this. You shouldn't do this. You can't start your normal and type in forward between 80, 90. Now you can put that into your machine. Normal, 80, 90, between. And it will give you an answer that is wrong. And why will it give you an answer that is wrong? Because if you put in 80 and 90, it's thinking you're on this curve, and 80 is 80 standard deviations, which is somewhere with an IQ of like, I don't know, 8,000 or something like that. So you have to transform yes, we need a translation factor that takes this 90 right here and converts it into something on this curve that's a z. Yes. And then we need a translation factor that takes this 80 and converts it to something on this that's a z. And then when we're done, we'll have the area we're looking for, which is the same as that area over there.
-2 to -1.
So the question now is, what are those z's? What are those z's? Well, let's see. Let's see if we can reason through it. Okay. The standard deviation of this is 15. So here's 100. If I come down 15, that's going to be 85, right? That's 85. That's one standard deviation down from 100. Knowing that this is 1, what's 90?
Well, then it's got to be a half, right?
Why a half?
It's got to be half because it's half the distance to 100.
Is it? It's 2/3 down, isn't it?
Yeah.
Isn't it two? Check it out. Check it out. Check it out.
Okay.
This distance is 10. I didn't draw completely to scale because I'm not much of an artist. It looks like the midpoint, but it's not the midpoint, is it? This distance here is 10.
Yeah.
Right.
This distance is 5.
Right.
So if this is one complete 15 standard deviation down, this is actually 2/3 down from the average. So this z-score has to actually be 2/3 from 0. Like this one here, 80, has to actually be what? 1 and what fraction? 1/3. So actually, this guy right here, the z-score would be -2/3, and this guy right here would be -4/3. Now you all look extraordinarily sickened. Your head hurts. That's okay. Corey, you're good. You're good, Charlie. It's totally fine. Now here's the deal. That's a lot to process, especially when these numbers can and sometimes do get kind of messy. And they do, because reality is messy. I mean, heights and weights and things like that often don't have nice integral values like this. This is why, I think it was video 4 of that little set I had you watch, I was comparing Michael Phelps to Mark Spitz. You remember that? I don't know if you remember that. I was comparing who's the more impressive Olympic swimmer, Phelps or Spitz. Phelps had 8 medals, Spitz had 7, therefore Phelps is more impressive. That's ridiculous. You start looking at their times and you realize Spitz blew second place out of the water more than Phelps did. Yes, but he had that big mustache and it was the 70s. So then you say to yourself, how am I going to compare these two guys?
I feel like Bert and Ernie.
Essentially, if I was trying to compare them to each other using one measure, I was trying to just get an overall, it's the same question but asked in a slightly different way, in a more focused way. Very much that way though. The question is though, if I was to ask, for example, whose top score was more impressive with Bert and Ernie? Is Bert's 100 more impressive than Bernie's 83? Ernie's 83. So, right, one specific data point versus the entire set of data points. What I did with Spitz and Phelps was I ran a conversion factor that put them both on this scale. Because you got to think about it. When Spitz had his swim times from the 72 Olympics, there was a curve him and his swimmers were on. Phelps, by definition of how they train nowadays, his curve had to be lower than the 70s curve because they're getting faster in the water. They're wearing the crazy suits. They have more. They spend. You noticed if you watch a swimming from the 1970s versus 2013, how much longer they spend underwater when they dive in now. They used to pop right back up on the surface and start swimming. They've realized if they stay underwater and do more of the dolphin, they actually can get quite a bit more distance in a faster period of time. So you can't compare apples to apples. Did you catch the last place guy in 2012 was faster than Spitz in 72 in the same exact event? But that doesn't mean that Spitz is less impressive than that last place guy. What you need is a common measuring stick to compare them with. And that's what the formula. I've been very, very adamant about hiding formulas from you guys in this class. I can't stand them for the most part because you guys can't stand them for the most part and they get in the way of education. But there is a beautiful formula that you guys just used and you don't even realize you did it. You used the formula to figure out this was negative 2/3, this was negative 4/3. The first thing you did was you figured out how far apart these were from the average. And then you scaled that using the 15. So you said, okay, this distance right here is 10, and that's 10 over the entire distance of 15, that's 2/3. And you said this distance here is 20. I mean, you might not have done it exactly this way, but you essentially came to this conclusion. 20 over 15 is 4/3. That's called the z-score formula. I mean, that's what we're going to use. Let's swing this over here. To be able to convert between the standard normal and the general normal, G. This is the only formula you have to worry, and I'll put this on the board during your exam. Don't memorize it. Yes, you got it, Athena. To get the z-score, you take, I like to call them x's. X is a raw score. So x would be, and Cassie, you said it, I'm envisioning the 80 and 90 on the horizontal axis. Yes, this axis is generally called the x-axis. The standard one is called the z-axis because it's a very specific one. That's where your average is 0 and your standard deviation is 1. Everything else we just call x. Kelsey. You take x, you subtract off the average to get that distance they are apart, and then you scale it with the standard deviation. And that converts it for us right to a z-score, which is essentially what you guys just did, conversationally. But this takes the, I don't want to make you feel sick to your stomach. You said you felt headachy or sicky over there, Cass. I don't want you to feel headachy or sticky. This gives you a nice, I try to hide formulas from you guys whenever I can, unless I think they're useful, and I think this one's useful. I think this one's useful. And there's a reason I could have written a program to do this for you, but this is a wickedly important formula for those of you taking 244. It's pretty much the crux of our course, of why we use it every single day to convert things back and forth. So I want you to get used to using it. So let's use it right now. Let's get both of these numbers so that you can see how they get used. So you can see how they get used. Okay? So 90, to get the z-score for 90, we're going to take that raw score of 90. That's your x. That's your x. Watch, swing this back over. In case you need this later. Okay. We're going to dump off the average of 100. And all that tells us is how far away it is. It's negative 10. 10 below. 10 below, which is totally fine. Totally fine. But that in and of itself tells us nothing without the standard deviation. If the standard deviation is 1 and you're 10 points below, that's ridiculous. You are 10 standard deviations away. That's silly. There's something wrong with your test score at that point. But when the standard deviation is 15, that negative 10 scaled by the negative 15 tells us you're only 2/3 of a standard deviation away, which is well within 2 standard deviations, which is, if you will, normal with the 95% rule. That's where your 2/3 came from. And your 4/3, your negative 4/3 came from the exact same thing. Came from the exact same thing, except you start with a different raw score. You start with 80 instead of 90. That's a Z, by the way. My apologies. Negative 20 over 15, which reduces to negative 4/3. And now you've got the z-scores you need to use the normal. Now you're on the normal curve. And essentially, not essentially, literally, this area that you find here will be the same area that you have over there. Let's go do it. How many dull, normal folks do we have out there? I don't know. I don't know. Let's find out. There we are. Light on that, maybe. Oh, ask me that question, Athena. Ask me that question. Is it forwards or backwards? Forwards or backwards?
Forward.
Definitely forwards.
That was my question.
I just rigged your mind.
He knew that.
Between left or right? Definitely between. Definitely between. Left bound,
Negative 4/3.
-4/3. You can put fractions in, it's totally fine. Right bound, and make sure you get them in the correct order, otherwise they'll get pissed at you and give you an error. And that's okay. It's okay. Here it comes. That's right where it should be. So it tells, oh, that's really dark.
It's not under the light.
It's not, is it? So let's do this. Oh, God.
Can you just move the light? No, you can't.
I'm trying to capture it on the let me see focus too. Excellent, Corey, go for it. Can you crack the, you might have to crack the, see the little wing nut, or just do that. There you go. It's perfect. So, we got ourselves, got it before you wrote it. So you don't have to sit there and hold it for indefinitely. There we go. So, how many dull normal folks are out there? Ish, give me a percentage. 16%. Dull normal. There are 16% of folks out there that have an IQ between 80 and 90. Which means there are also 16% of people out there that have an IQ between what and what?
Above dull normal.
Good, whatever we would call it. We call it bright normal or something like that. 2/3 and 4/3, which would be 110 and 120. We know that by symmetry, don't we? We know that by symmetry, don't we? Between 110 and 120. Beautiful, beautiful. So I know. So that's the big idea. We didn't get in any backwards problems today with the normal. With John normal into the normal. We'll get some more of those on Wednesday of next week. But Jeff, I hope I answered your question about backwards as far as the general backwards program goes. Great question. This gets interesting as soon as you start on Wednesday of next week. I'll revisit IQ because now you got that in your mind. Probably forget it between now and then. That's fine. And then we'll look at human pregnancy, which is an interesting way of looking at it. And then we'll look at a whole bunch of other stuff as we finish the course out.
We should study it when like they have the brownouts and the blackouts in New York.
I don't know what that is.
No, basically, like it was for like pretty much everybody that was like. You didn't hear about the huge numbers of babies that were made during the brownouts and the blackouts.
Oh, that's cute.
Because
No,
they
that's
had,
cute.
like people
No, that's adorable.
hadn't looked at each other for like
Hey,
15
that's
years.
adorable.
Like 15 years, basically, we were born and made babies.
Oh, no. I remember hearing that October 5th was the most popular birthday for years. Because it was 9 months after New Year's Eve.
Yeah, that too.
Yeah.
And alcohol was the fact.
October 5th?
October 7th.
October 7th. There you go. All right, Frank.